Hi, my name is Yash, and today I'll be presenting the Physics 2212 Lab 3. And a bit of an intro about the lab is that the purpose of the experiment is to measure the distance dependence of a magnetic field due to a small bar magnet. And several concepts, models, and equations will come into play, including the Biot-Savart law and the magnetic field of a dipole. And you can see some of the equations here tell us how to compute the magnetic field of a dipole. And then the equation on the bottom is going to be the equation of two of the things we graph. And I'll talk about that later on. So as far as the actual experiments goes, there's both a system and the surroundings, and the system is simply going to be the magnetometer app on your smartphone or whatever you're using, and the surroundings will be the bar magnet generating the magnetic field. For the procedure itself, the materials needed would be tape, the bar magnet, the magnetometer, and a meter stick. And then the next thing you need to do is orient your phone so that the X component is 0 on the magnetometer app. And then you're going to find the magnetometer chip as explained in the lab instructions. Then there's two different values we're going to need. We're going to need to calculate the on-axis field and the off-axis field. So to measure the on-axis field, you're going to calculate the on-axis distance between the magnet and the magnetometer when the magnetic field has a value of 20 teslas, 70 teslas, 120 teslas, 170 teslas, and 220 teslas. And you're going to repeat 3 times for each of those magnetic field values. Then you're going to compute the off-axis field, which is where you calculate the off-axis distance between magnet and magnetometer when the magnetic field is 100 teslas. And then you're going to measure the y component of the field and then move the magnetometer to this y distance, and then finally measure the magnetic field with components in the x, y, and z direction. And you're also going to repeat this 3 times to get accurate results. So these are the results of the experiment. On the left, you can see the values from the on-axis field, and then at the bottom, you can see the values from the off-axis field. And one thing to note for the off-axis field is that the d value is approximately 0.2, and this will be important later on. And then here you can see that when we graphed the x component of the magnetic field versus the r value, we get an equation that's resembling y equals negative 3.2453 with x minus 14.808. Then here is the coding I had to do. So the dipole moment can be computed as shown here, and then we're orienting the various the various magnetic field vectors. And here on the next page, you can see the results of that. You can see that the axis 1 and axis 2 magnetic fields have the same value, and then the perpendicular 1, 2, 3, and 4 have the same values, but it's different than what's in the b axis 1 and b axis 2. And the d value here is also 0.2 roughly. So this is very similar to value I was talking about in the coding. And then the b at 45 degree, but the distance d is given by this value right here. To go on to the discussion and conclusion, there could have been errors in several possible ways. For example, the magnetic field may have been impacted by other things with charge, like the desk, ceiling, and floor, which could have led to inaccurate measures because each of those objects have a charge that could interfere with the values we're looking for. And then the magnetometer itself may have had inaccurate measurements. When I was doing the lab, in the first 3 trials I did, I realized my values were completely off, so I had to redo them. And the distances may have also been off due to rounding. I mean, the meter stick, we might have rounded a bit incorrectly. And then to answer the discussion questions, for the first question, if we oriented the experiment to compensate for magnetic north, it would have changed the magnetic field because the x component and y component would have changed quite a bit, but the z component would have stayed the same. And then if we were to stick 2 identical magnets together and run the experiment again, I think the magnetic field would increase because now you have the magnetic field coming from 2 different magnets. And in this, the concept of superposition would come into play.